Station, this is Houston. Are you ready for the event? Copy that. Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. Are you ready for the event?
We are ready for the event and have you loud and clear.
Please stand by for opening remarks.
Hello, I'm Mr. Trimberger, and I'm the superintendent for the school district of Random Lake. And I'd like to start by saying how honored we are to host this event. I'd like to give some special thanks to Mrs. Barber for making this event possible, and also thank all the students for submitting all their questions. And with that, let's get to question number 1.
Hi, my name is Suji, and my question is, can bacteria or viruses spread in space?
Just like on Earth, we have bacteria and viruses all around us, even up here on the space station. Most of the bacteria up here we track, and we make sure that they're not spreading too fast or getting to be too high of a quantity to keep us safe. But we actually need bacteria to keep us healthy, too. We also quarantine before we launch to space, so we really limit our contacts with other people and get tested for a lot of sicknesses before we launch, just to make sure we're not bringing any sicknesses or illnesses up to the space station.
Hi, my name is Nicholas, and my question is, can there or has there ever been a fire on the space station, and how do you put it out?
Well, Nicholas, there has never been a fire on the International Space Station, but there have been fire on spacecraft before. There was one on the Mir space station, and there was a flame coming from an oxygen generator. It developed smoke, and cosmonauts and astronauts had to put it out. We all have water tanks, and we have CO2, carbon dioxide tanks, that we can put fires out with if we need to. But we learned from that fire, and we have a lot of safety measures in place now and a lot of new training that we've developed so that we can take care of a fire if it happens.
Hi, my name is Madison. My question is, can you have carbonated drinks in space?
Well, unfortunately, Madison, no, we can't, because on Earth, as Tom knows, I really like to drink sparkling water. But unfortunately, carbonated drinks up here would be kind of a mess. If you've ever had a can of soda kind of explode or foam over when you open it on Earth, just imagine how wild that would be up here in space. I think it would shoot the can off and there'd be splattered soda all over the place. So unfortunately, not yet, but maybe some cool scientist or engineer on Earth will figure out how to do that safely up here.
Hi, my name is Kayla. My question is, has anything big or little broken something on the space station or on an astronaut while on a spacewalk?
Hi, Kayla. There's always little tiny bits of what we call micrometeoroids that are hitting the space station. They're all around us. And so when Kayla and I did a spacewalk, we could see little tiny craters on the outside of the space station, but it's quite rare. Those big old solar arrays will take a hit every now and then. And with the electrical circuitry, they're able to route around it, and we're able to get our power. And so we're aware of it, but it's not a big problem.
Hi, my name is William. My question is, do animals act differently in space?
Hi, William. NASA is preparing to go on longer and longer missions to places like the Moon and Mars. So it's really important that we understand how different organisms will act in outer space, both people, animals, and plants that we might grow for food. So we do study animals and how they behave in space. And just like on the ground, there are scientific models like mice that we use to understand how organisms change, grow, and how they behave differently. One of the interesting things that scientists have seen mice do in space is kind of run a racetrack loop around their habitats. And they think they're doing that because they like the exercise. And they probably get a good response the same way you do if you are physically active on the ground. And they've even seen mice do that together as a group, kind of like a group activity. So they're not totally sure why they're doing it yet, but they're trying to understand that better. And just like those animals learn how to behave differently in microgravity, Tom and I have learned how to act different in microgravity too. We can float, work in different orientations, spin around, and so, yeah, we do act a little bit differently in space than we do on Earth.
Hi, my name is Isaac, and my question is, what specific jobs do you have on the space station?
Well, actually, we all have the same jobs. We all have to be or try to be good at all of our jobs. Specifically, we have to be scientists. We have to be research assistants for the scientists on the ground. We spend most of our time doing experiments up here. We have to be plumbers sometimes, IT specialists, electricians. But importantly, what we spend a lot of time training do is that all of us need to be able to do spacewalks and also to fly a robotic arm in case we need to capture a cargo vehicle as it comes up to the space station and dock it to the station so we can get resupplied. So we all have specific jobs, but we all need to be able to do them.
Hi, my name is Elizabeth. My question is, what is the coolest thing you have seen in space?
That is a tough question to answer, Elizabeth, but I would say one of my favorite views I've had is actually on our trip up here aboard the Dragon, our spacecraft. We actually had a 22-hour time period between our launch and arriving at the space station, so we actually slept aboard our capsule. And when we woke up, we were getting ready to start getting into our spacesuits for our arrival to the space station, and we looked out the window, and it was still nighttime. We were over a dark part of the Earth. You could see the thin layer of the atmosphere, stars everywhere, and the sun, although it was behind the Earth and it was still dark, was at just the right angle that it was lighting up the space station, which was on an orbit a little bit higher than us and ahead of us. So the space station was glowing bright gold. You could see the perfect outline, including the whole shape and the solar arrays, and it was just so awe-inspiring. We weren't even used to those views yet. This is my first mission to space, so it was incredible to see our destination while we were aboard our capsule.
Hi, my name is Chase, and my question is, if Earth has gravity and the moon has some gravity, why is there so little in space between them?
Hi, Chase. Great question. You know, gravity is all around us all the time. Even though we're a little distance from the Earth, about 250 miles away from it, we still get 90% of the Earth's gravity. The moon's gravity is pulling sort of in the opposite direction when we are in between those two planetary bodies. So they cancel each other out. The main thing that we feel here is the gravity of the Earth, and the way we feel it is that we stay in orbit. Our velocity is so fast from our rocket, over 17,000 miles an hour, that we would fly away from the Earth except for the fact that the Earth's gravity keeps pulling us back. And so we do this almost a circle around the Earth, and that's what an orbit is. So gravity is very important to keep us here. We don't feel the effects, though, because we're falling around the Earth, really, along with the space station and everything around us.
Hi, my name is Mason. My question is, what was it like experiencing Earth's day cycle from the space station for the first time?
It was absolutely incredible. Every 90 minutes or so, we have a sunset or a sunrise aboard the space station, and it's amazing. You actually get to see the line between day and night move across the Earth. We call that the Terminator, and the sunrises and sunsets are incredible. The colors are beautiful, and you can see clouds lit up, really high atmosphere clouds, and it kind of fades from this really bright cobalt blue, these burnt oranges, beautiful colors, and sometimes we even get to see auroras at night. And so it's actually absolutely amazing to see these cycles, and pretty much anytime you look out the window, there's something incredible to see.
Hi, my name is Peyton, and I was wondering, on average, how much oxygen you'd use on a spacewalk in 7 hours.
So if you measure oxygen, you can actually measure the mass of it. And so almost about 2 pounds of oxygen we'll use. We have plenty of oxygen in our tanks to support us for about a 6.5-hour spacewalk. We can go longer in case we have to get more work done. People have gone out more than 8 hours, even 8.5 hours before we start to be a little bit concerned about running out of oxygen. But there's plenty of it for us to use. It is 100% oxygen. We're not breathing the air inside the spacesuits, and that's to help us be able to operate at the low pressure of the spacesuits. But it all seems to work out.
Hi, my name is Paisley. My question is, how many shooting stars do you see in one day?
Well, Paisley, I think that really depends on how much time you have in the day to look out the window. On work days, we all make sure that we look out the window a couple times a day, and on the weekends, we spend more time looking out. I asked Tom, since he's spent more time in space, how many shooting stars he's seen in space, and he said 2. I actually just saw my first one the other day. And the thing that's hard about it is we're looking mostly down at the Earth. Most of our windows are oriented towards the Earth, and so the stars we can see are just those that are kind of above the Earth horizon between that and our spaceship. So you have to be looking at just the right time, just the right angle, but it is pretty spectacular if you see one.
Hi, my name is Neva. My question is, what happens when someone gets sick or needs emergency surgery, like for the appendix?
Well, that's a great question. I happen to be a doctor. It was one of the things I did before becoming an astronaut. And so we have on the space station a medical kit. This one is full of pills in case you get a little bit ill. And here's a map to show you where everything is, because you don't have medical specialists up here to tell you what to take or where it is. So this is all very helpful. If we get sicker than that, we have specialists on the ground that'll help us. We have more supplies to take care of you like maybe you would be in a hospital, but only for about 24 hours. So the last resort is, if people get really sick, we'll have to bring them home, and we use our capsule, the Dragon capsule that we use to fly up here. We would use that as an ambulance to take us home.
Hi, my name is Marin, and my question is, would a baking soda and vinegar volcano, if done in a container, react the same in space?
Well, Marin, water, any liquid really, behaves a bit differently up here, so the reaction would happen a bit differently. Similarly to what you probably have tried yourself in a science experiment, that acid-base reaction creates a lot of bubbles that look like a volcano exploding, which is why it's so much fun. That experiment has been tried up here. Basically, we floated a sphere, we didn't do it, but the previous astronauts floated a sphere of vinegar and then put in an anti-acid tablet, and that bubbled up and basically expanded equally in all directions, as opposed to just kind of bubbling out of the container. So I think it sounds like it went pretty well, and you could do that experiment up here too.
Hi, my name is Jackson, and my question is, what is the most valuable item you've lost on the space station?
Well, you know, working in zero gravity, or what we feel like is zero gravity, is hard. Gravity is very helpful to help us organize things, put them on a table, and things on Earth don't move around. But here, things can get away from us. They do all the time. So occasionally you lose something. Probably for me, the most valuable thing was a piece of experimental hardware. And, you know, on the ground it might not have been that expensive, but up here it takes so much time to work for people and planning for people to get their hardware up here. It's always it makes you feel kind of bad when you lose something, but we're human beings and occasionally it happens.
Hi, my name is Levi, and my question is, what is the most exciting experiment you've done on the space station?
Well, Levi, I've done a lot of experiments that I found pretty exciting. Some of my favorites are the plant experiments that we do up here. We grow plants so that scientists can study how their genes change in space, and we also grow plants that we get to harvest and eat sometimes, which is really exciting to get fresh food. We also have some cool robots that can fly around the space station and do a bunch of different tasks. The scientists are trying to teach them how to do things so that we don't have to do them ourselves, like move objects or inventory things. And one really cool thing I did a few weeks ago is I set up a miniature scanning electron microscope that can image things that are really, really tiny. And it's super cool because it means we could use it to identify materials or study how they change in space. So that's pretty neat, and we've got a lot of cool experiments going on every single day.
Hi, my name is Olivia, and my question is, if you weren't an astronaut, what would you be?
So that's easy for me to answer. I was a doctor before I became an astronaut, and I'd probably keep on being a doctor. I had the joy of being a doctor for astronauts and pilots in particular, and worked in the ER. So I think I would keep doing that, a combination of that. What about you, Kayla?
I'm actually an officer in the Navy, and before I became an astronaut, I was working on submarines as a submarine warfare officer. So if I wasn't an astronaut, I might be deployed on a submarine somewhere in the ocean right now.
Hi, my name is Morgan. My question is, we watched a video that said there's a 100-question checklist before you go on a spacewalk. What does that include?
Well, Morgan, our spacesuits are kind of like miniature spacecraft or spaceships that we fly ourselves, because we need everything we need in a big spaceship to keep us alive while we're outside. So that means systems that deliver us oxygen to breathe, remove carbon dioxide so that we can continue to breathe that oxygen, keep the pressure up so that we can stay alive, and also keep us cool. And so those checklists check every single one of those systems and make sure they work before we go outside so that we can both stay safe and accomplish our mission. It actually even takes a couple of weeks of pretty hard work to get ready to do a spacewalk, just getting all the equipment ready, all our tools checked out, and preparing ourselves so that we understand all the procedures we'll be executing when we go outside.
Hi, my name is Jackson. My question is, what made you decide to go to space?
Well, Jackson, I think for a lot of astronauts, I didn't decide necessarily. I just wanted to go. And I can't tell you why. It's almost like space chose me. I was about your age when I started reading books about space, and I couldn't believe that human beings did it. I couldn't believe there were engineers and planners and scientists on the ground that figured out a way for us to do this incredibly audacious thing of putting people in space, not to mention a laboratory, and to go to the moon and walk on the moon. So I just fell in love with it. I can't quite explain why, but then I planned my life from then on to just to at least work in this space program if I could, and suddenly I found out I could be an astronaut too.
Hi, my name is Riley. My question is, why does the space station have the shape that it does?
Well, Riley, right now we're in Columbus module, which is a pretty standard sized space station module. The size and shape was actually based on what the space shuttle could carry. That's actually how we delivered the individual modules of the U.S. segment to space. It was in the payload bay of the shuttle, so they're cylindrical. They're all about the same size. We kind of, on the U.S. side of the space station, we have modules down the middle and then also going off right and left. And on the Russian segment, they go down the middle and up and down. So it's a little bit different when you go to the Russian segment. Things are oriented a bit differently. But basically, they were trying to maximize how much cool equipment they could get up on every launch. And that's kind of how you got the shape you see here today.
Hi, my name is Jackson. I'm very excited to be here. My question is, what research are you doing on the ocean from the space station?
There's actually right now on the space station a lot of interesting experiments going on. There's one radar, for instance, that's looking at the surface of the ocean. Turns out a lot of weather is determined by temperature and humidity and the wind and the waves of the oceans. And so we have special radars and special sensors that are looking at that. And so we can improve weather prediction, get a better idea of why climate changes the way it does. And that's been going on both on the Earth and on the coastline, but specifically over the oceans. That's going on right now. But there's been an enormous amount of work that continues to go with regard to our oceans.
Hi, my name is Scarlett, and my question is, if you had the chance, would you go to the moon or Mars?
Absolutely, Scarlett. I would absolutely love the chance to go to the moon or Mars. And in fact, right now, as part of the Artemis program, we're getting ready to return to the moon to send human beings to the surface of the moon, not just to visit, but to stay permanently, to live and work in habitats, to use resources on the moon, like find ice that we can melt and use as water to drink or make fuel. And so we have so many exciting things going on. The first Artemis test launch should be be pretty soon, actually, maybe even while we're still up here. So we're hoping to see it from space. So yes, absolutely. I think I would love the chance to go to the moon or Mars if I ever get the opportunity.
Wow, what a wonderful event. Thank you to our astronauts for making this such a memorable event, and thank you to all our students for making this so much fun. And with that, this is Random Lake School District signing off.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants. Station, we are now resuming normal operational audio communications. Thanks.